This machine shouldn't be able to do this. In under a second, it sorts, guts, and packs a fish with surgical precision, and it does this 50,000 times every single hour. Today, we are inside a Moroccan facility that turns a delicate catch into a global product at a speed that feels almost impossible. Most people assume canning is a slow, old-fashioned process, something closer to a kitchen than a factory. It is not. How does a machine handle a fish this small, this fragile, at this speed, without crushing a single one? How do you take something as delicate as a sardine and turn it into a shelf-stable product that can sit in a cupboard for years, safe to eat long after the fish itself would have spoiled 100 times over, with no refrigeration and no preservatives beyond salt and heat? That is exactly what we are about to find out, step by step, machine by machine. It starts with the catch. Sardines are landed by purse-seined fishing boats, and from that moment, it's a race against the clock to get these fish on ice before they spoil. Sardines are one of the most perishable fish in the ocean, far more delicate than tuna or salmon, but you cannot simply tip thousands of loose, randomly oriented fish into a canning line. Every sardine has to be facing the same direction before the machine can do its job. This is where the grading and orientation systems take over. Vibrating tables and water flumes move the fish along, using nothing but motion and gravity to naturally flip and align each sardine so its head faces the same way as the one beside it. A piece of pure physics doing a job that would otherwise take dozens of workers standing at a table. An automatic grading machine then sorts the fish by size, using diverging rollers set at different widths, capable of processing between 1 and 2 tons of sardines every single hour. Getting the fish sorted and aligned sounds simple. It is not. The real challenge is doing this at industrial speed without a single human hand touching the fish, and without damaging the delicate flesh before the fish has even reached the cutting stage. Sorting them is impressive, but wait until you see the machine that handles the heads and tails. That is where the engineering gets truly surgical. This is where the engineering becomes genuinely remarkable. The sorted, aligned sardines move onto the nobbing machine, an automated cutting system that removes the head, the guts, and sometimes the tail in a single continuous motion. A single nobbing unit can process up to 350 fish every minute. Optional dual cutting configurations can push that figure as high as 500 fish per minute. Circular blades make the cut. Vacuum suction removes the viscera instantly. Sensors monitor the size of each fish as it enters the machine and adjust the blade position in real time, because a sardine that is 11 centimeters long needs a different cut to one that is 15. Get it wrong, and you either waste usable flesh or leave bone and gut material in the can. Neither is acceptable. This is the difference between a perfect tin and a rejected batch. Skilled technicians monitor the sensor readings continuously, ready to intervene the moment a size distribution shifts unexpectedly. After cutting, the fish pass through a washing stage that removes blood, scales, and any remaining slime, using potable water or clean seawater before moving on to the next stage of the line. Every one of these steps happens in seconds. Multiplied by 50,000 fish an hour, the margin for error across the whole system is close to zero. Now comes the part that looks, on camera, almost hypnotic. The cleaned, headless sardines are packed into pre-washed cans, by hand on precision-guided lines, or by automated packing heads with exact positioning. A skilled human packer can still outperform a machine on delicate placement, which is why many of Morocco's top canneries, the largest exporter of canned sardines on Earth, still rely on human hands, working alongside conveyors calibrated to keep the line constantly fed. This is the rhythmic, satisfying motion that keeps a factory like this running 24 hours a day. But the system is not infallible. If a fish is misaligned, or a can arrives on the line out of position, sensors detect the fault and the line briefly diverts or pauses that unit while the rest of the process continues uninterrupted. One malfunction does not stop 50,000 sardines an hour. It stops one can, corrects itself, and the line keeps moving without the workers around it even breaking stride. Once packed, the cans move to a weight control station, where every single one is checked before continuing onward. Because an underweight can is a legal violation, not just a quality issue. Before sealing, most sardines are pre-cooked. We don't just add the oil and cook it all at once. If we did, the moisture from the fish would ruin the sauce. That is why they hit the flash cooker first, steamed at around 95 degrees Celsius, then dried in hot air at around 130 degrees, firming the flesh and preparing it to absorb the oil, brine, or sauce that comes next. Once cooked, the liquid medium is added, most commonly olive oil, sunflower oil, brine, or tomato sauce, and the cans move to the sealing stage. An automatic seaming machine crimps the lid onto the can using a precise double-fold seam, creating an airtight, hermetic closure. These machines can seal between 3,000 and 4,000 cans every hour. The seam is the single most critical mechanical point in the entire process. If it fails, contamination gets in and the product is unsafe. That is why seam integrity is a core food safety control point, tested on every production run using precision gauges. A defect invisible to the naked eye can still spoil a can months after it leaves the factory. It sounds like overkill, but one microscopic gap in that seal is the difference between a perfect meal and a dangerous mistake. The sealed cans now enter the retort, a specialized industrial pressure cooker that sterilizes the contents using high-temperature steam. The internal temperature typically reaches 121 degrees Celsius, held under precisely controlled pressure for a set period of time, calculated for the exact size of the can. This single step is what transforms a perishable fish into a shelf-stable product that can sit safely in a warehouse or on a supermarket shelf for years without refrigeration. Modern retort systems are fully automated, with sensors ensuring uniform heat distribution throughout every single can in the load, so there are no cold spots where bacteria could survive and no shortcuts anywhere in the cycle. Get the temperature or timing wrong, and the consequences are serious. Undercooked cans risk botulism, one of the most dangerous foodborne illnesses known. This is why retort operation is one of the most tightly regulated steps in the entire canning industry, monitored constantly and carefully logged for every single production batch. After sterilization, the cans are rapidly cooled, usually by cascading water over the racks, which stops the cooking process instantly and locks in the texture and flavor developed during the cook cycle. Once cooled, the cans are dried and every seam is inspected again, this time for deformation, leakage, or pressure failure that may have occurred during the sterilization process itself. Because the retort's own pressure and heat can expose a weakness the seaming machine missed. From here, the cans are labeled with product information, batch codes, and expiry dates, then packed into cartons and palletized for shipment. Morocco alone exported over 150,000 tons of canned sardines in a single recent year, making it the largest exporter of canned sardines on the planet, more than any other country in the world. The country's Atlantic coastline sits above one of the richest fishing grounds anywhere on Earth, where cold, nutrient-rich currents rise to the surface and sustain enormous sardine populations, giving Moroccan canneries a near-endless supply of raw material most other countries simply do not have. The global canned sardine market is now worth more than $6 billion a year, and demand keeps climbing, driven by sardines being one of the most affordable, protein-dense, shelf-stable foods on Earth. A can that costs less than a coffee, with a shelf life measured in years rather than days. A single 100-gram serving delivers over 1,480 milligrams of omega-3 fatty acids, more than most people get from an entire day of eating. Every stage of the process you have just seen, grading, cutting, packing, cooking, sealing, sterilizing, happens continuously, every hour, in facilities running 24 hours a day, 7 days a week, to keep supermarket shelves stocked with a product most people open in seconds and think nothing more about. This factory is not just about speed, it is about preserving a moment in time. A fish caught at sea this morning, sealed inside a can by this evening, safe to eat years from now. 50,000 sardines an hour, sorted, cut, packed, cooked, and sealed by machines engineered to a tolerance of a fraction of a millimeter, with almost no room for error anywhere along the line. Every can that leaves this factory has passed through a dozen separate checkpoints, any one of which could have stopped it. A size sensor, a seaming gauge, a temperature probe, a human eye. The ones that make it through are sealed, sterilized, and ready to sit on a shelf for years, all because of a process most people will never see and rarely think about while eating breakfast straight from the tin. Think about what actually had to happen for that can to exist. A fishing boat found the shoal. A grading machine sorted every fish by size in a fraction of a second. A nobbing machine cut 350 of them a minute without a single mistake. A retort held pressure and temperature to a standard that prevents one of the deadliest illnesses in food science. None of that is visible from a supermarket shelf. All of it happened anyway, quietly, every single hour, for the can sitting in your cupboard right now, waiting to be opened without a second thought. If you think 50,000 sardines an hour was fast, wait until you see what it takes to pack 100,000 sausages an hour. That is next.